Okay, right. Let us carry on with these questions. This is question 29. We'll probably go question 29 all the way to, I'm hoping, 33, but let's see. Um, so, which of the two are not usually characteristic of a modern manufacturing environment? So, a modern manufacturing environment, really, we're talking about use of, really, this is chapter 4. So now you want to have read chapter 4 before you attempt these batch of questions here. So modern manufacturing is, if you like, lean manufacturing, just in time policies, just automation, so to speak. And we are getting better at reducing waste, measuring costs and the causes, and if you like, the drivers of those costs. So what we would typically see, doing this kind of the other way around, is to look for the characteristics of it. So we could almost, by process of elimination, find out what those, which ones aren't usually characteristic. So what do we tend to see with modern manufacturing environments? We tend to see shorter production cycles. We see a greater emphasis on quality. We see a greater use of advanced technology. We do not see an increased rigidity in the processes. In fact, we see a reduced rigidity because machines are doing the work now. Reduced levels of employee participation. No, that doesn't. There's no direct correlation between the two. Just because we're automating doesn't mean we see a reduced level in employee participation. We have employee participation operating, if you like, at more technical levels and at more inspection levels. If you like, at more strategic levels. So 1, 2, and 3 are characteristic, and therefore the answers are 4 and 5. If you like, the fourth one and the fifth one. I'll just go to the. So question 29. It's the fourth one, fourth answer, and the fifth answer to do with rigidity and employee engagement. Okay, right. Let's come out of that. I wonder if it makes the ping noise it makes when I come out of that PowerPoint. Apologies if it does. Okay, great stuff. Now let's look at this. So a company produces a range of products and uses an absorption costing system. Okay, great. So if you've read chapter 4, you will know that ABC is a much more evolved form of absorption-based costing. So which two of the following are unlikely to be consequences of a company that is switching to ABC? So if you're switching to ABC, you're switching to a much more refined system that is better because of the amount of investment that's gone into to if you like, finding out what the cost drivers actually are. There's a better chance of those costs being, if you like, shared on a fairer basis. So indirect overheads, and remember the focus here is very much on overheads. We do not have issues with our direct costs. So indirect overheads will be shared between products on a fair basis. This is true. This question says unlikely, so I'm going to highlight which ones are the consequences. So here we are. So these are the consequences. We will have indirect overheads being shared fairly between products on a fair basis. That's true. As a result of that, naturally, product pricing will be improved because if you're using a markup basis, of course, then we have better pricing decisions. What is interesting here is this a little trick question. The prime costs, which is direct costs. Direct costs are not affected here. If you remember, all these systems very much focus on overhead. So prime cost production will fall. No, that will remain the same. There's no consequence. Prime cost of direct material and direct labor. Cost control on indirect overheads will be harder to achieve. No, on the contrary. We know what's driving the cost. If we can control the driver, we can control the cost. Total production of each product will change. So that is definitely true. That's a consequence. So the prime costs of each is not a consequence, and yeah. So here it is. Which two? The prime production will fall. That's not a consequence. And for number 30, here, what we also see is I think I said here, cost control. Yes, this is not true. Cost control on indirect overheads will be harder to achieve. No, that's untrue. It will actually be easier to achieve because we know what's driving those overheads. So 3 and 4, the third point and the fourth point. So question 30, the third answer and the fourth answer are the correct answers there. Okay, right. Let's come out of that. Let us move into question 31. This is our first calculate type thing. So what I will do right now is I will just I could have done this earlier on, but it doesn't matter. I can do it as we're speaking, and I will snippet that out up there and put it onto a PowerPoint so we can play with it a little better very quickly. Yes, let's just save that. If you like, and just call that capture. Okay, let's just come here. Let's come in here, and let's just insert that very quickly. Picture. Style capture. Okay. Okay, great stuff. Okay, great. So let's play with this. So what we have here is a picture. It says a company, this is 31, which makes two products, Alpha and Zeta, uses ABC to absorb its overheads. Okay. Our focus is on that overhead cost of this 250. It's identified a new overhead cost pool for inspection, and it wants to use this as the number of inspections. So the argument is that inspections are driving this cost of 250,000. So very good. It's very important to watch this very carefully, and then really tease out what's happening here. We're focusing on inspection. So it says inspection per batch. So it's 4 inspections per batch. That's fine. The question here is therefore how many batches are we dealing with, because our aim is to get the total number of batches, so we can get some kind of overhead absorption rate, if you like, an overhead per batch type thing. Well, we know that you're making 2,500 units, and if there are 500 units in each batch, it must mean in total in this period there must be 5 batches, right? Because it must be 2,500 divided by 500. So we have 5 batches in total. And if you have 5 batches in total and you're having 4 inspections per batch, so that's therefore you must be having a total for alpha of 20 inspections. Let's look at Zeta. Let's do exactly the same thing here. You have 8,000 production, 1,000 units per batch. So naturally that means that is 8 units or 8 batches, if you like, right? Because you have 1,000 batches, 1,000 units in a batch. So if you have 8,000 units, you must have 8 batches in total. Now, if you're having 1 inspection per batch, so that means that's a total of 8 inspections. And if you're having a total, therefore, of 250,000 for all these, that means that we can then work out what the total, if you like, what the inspection, the overhead absorption rate is for each inspection. So that's 250,000 divided by 28. My calculator's oh, there it is. Thought it had gone walking. So here we have 250,000 divided by 28. And therefore we have 8,000. I would leave all this in my calculator to make sure you carry on with your working. 28 plus 57. So that's what you have, if you like, per inspection. Now we know that and they want us to look at alpha, and you know that for alpha you need 4 inspections per batch. So this is what it is per inspection. So if you need 4 inspections for one batch, I will therefore need 8928.57 times 4. So this will be the total cost of inspecting one batch, and that therefore gives me a total figure of 35,714.28. Now, I know the question is asking me what's the inspection cost per unit, and in each unit I have 500 units in one batch. So therefore, if I have 500 units in one batch, this is the equivalent. This is for 500 units. If I'm looking for 1 unit, I would have to divide this by 500. When I do that, divide that by 500, that brings us to the lovely figure of £71.42. 428 sort of whatever sort of thing, and that takes us kindly to taking us back to the answer. You can see 71.43. So your answer is 71.4.43. Let's just go here. So question 31, 71.43. Okay, question 32 and question 33. We'll sort of do them in that sort of order. So question 32. So it says, which of the following are true regarding ABC and cost drivers? So a cost driver, so for example, inspections, like we've just done here, the number of inspections, that's a cost driver that causes the change in the cost of an activity. Well, that's true. If you have the actual inspection, if you like, if you're talking about the cost of inspections, there is a direct correlation between inspections and the number of inspections that are carried out. Inspection costs and the number of inspections that are carried out. That is true. So definitely that's correct. For long-term variable overheads, the cost driver will be the volume of activity. I like the fact that they've given us the hint here that it is variable, and variable denotes, connotes, or highlights the fact that volume is the driver here. Direct correlation between volume and variability. And so the volume of activity will definitely drive variable overhead costs. So that is very correct. Variable costs are driven by volume. And then traditional absorption costing tends to under-allocate overhead costs to low volume products. Well, you see, the thing is, that's actually the whole point. The traditional absorption costing has always been very much about volume. It's always said that whoever's making, because you see, typically, whether we say hours, 10,000, whether we say hours of labor, or whether we say machine hours, the argument generally, traditional style, is that the more units you produce, the more hours you would need of both labor and machine time. And therefore, the less hours you produce, the less labor and you would need. So therefore, it will split whatever overhead cost it has based on that that volume, according or giving less to the product that has less hours. And so that's true as well. We'll see that with ABC, takes a different approach. ABC is not driven by volume, but if you like, what's actually causing the overhead. So volume in itself might be insignificant when it comes to ABC. This 1,000 might be a really important vaccine, which has an overhead that has, this might be simple Panadol. So you can see you might have overheads here that are so much higher than here, simply because of the nature of the product. So the answer here, of course, is due to traditional absorption costing. Yes, it is true that there tends to be an underallocation of overhead costs to low volume products. So the answer is D. All three are correct. All three are correct. Yes, 32 is D. Right, let's look at question 33. 33 here. This is the last question we'll do in this batch. So again, let me just quickly snippet this out. Next time I'll do these in advance, but it's okay. We're in a row, so we can do it as we go along very quickly. Snipping. Yeah, let's take this out of here. Boom, boom, boom. Yeah, we'll do that. That's right. Okay, right, let's look at this one. So company makes product A and B, experimenting with activity-based costing. Production costs are set up at 12,000. So production costs, so just each production production setup costs are, this is the total. So this total production will be 20,000 units of product A, and both 20,000 of each of A and B, and each production run here will be 1,000 units. So therefore we will have 20 production runs, right, to get to 20,000 units, and here it'll be 5,000. So we will have 4 production runs. So therefore we will see a total of 24 production runs. Now we have setup costs of 12,000. So therefore, it means that if you have a total of 12,000 and you have 24 production runs, therefore each setup cost, if you like, will be 12,000 divided by 24, which is equal to £500. So you will have £500 per setup. Now, each run, in this case here, for A is 1,000 units. So every time you have a run, you spend £500 to make, if you like, to sort out 1,000 units. So therefore, because I'm just focused on, if you like, a unit, I mean, I know what happens when I have a run. I spend £500 to make 1,000 units. Therefore, the setup cost per unit of A, if you like, right, will be, well, I'll just divide this by 1,000 and divide this by 1,000 as well, and therefore I'll have 50p, if you like, as my setup cost per unit of A. If this question had been asking it for B, it's £500 per setup, and it's 5,000 units of B, so therefore I would have divided this by 5,000, so I'd have had 10p here, 0.1, 10p, so 10p for B, but 50p for A, so the answer is 15p. Okay, cool, great. That brings us to about our 15-minute mark that we seem to be sitting at, and then yeah, in the next video we'll tackle the next set of questions.